Okay, so today we're going to talk about congruency and similarity, which we've done in isolation, but we're going to now relate it to transformations and how congruent shapes, which are equal shapes, relate to translations, reflections, and rotations, because those three transformations create images that are congruent to the original. So congruency means that the shape is the exact same. It's basically like you cut and paste it, or copied and pasted one shape and created another shape. So the corresponding angles and the corresponding sides are going to be equal to each other. And we're going to know this by two ways. The first way are these fun little lines. One line and one line will show you which sides are congruent. Two lines, they're congruent. Three lines. Same thing with angles, except now instead of a straight congruent line, it's going to be a curved congruent line. So this angle is congruent to this angle, and so on. The second way that you're going to know that they are congruent is, and we've touched on this a bit, is the fact that there's usually congruency statements. So you can see that triangle yes is congruent. So this equal with a little squiggly similar symbol is congruent to triangle fun. That means that when you go through the letters, angle Y and angle Y and angle F are going to be congruent because they're the first letters in the congruency statement. And so therefore E and U are going to be congruent to each other, and S and N. We can also say which sides are congruent to each other because of the order of the letters. So UN, side UN, remember we call line segments or sides using the little line segment line. So UN is congruent to ES. If you want, you can go ahead and fill this slide out, but it's very basic and I feel like we've done this before. So I will do the first three. Right? We already said that ES and UN are congruent, and we don't even really need the triangles to tell us this. We just need the congruency statement. We know that angle E would be congruent to angle U because they are together in the congruency statement. And then YS and FN are congruent. So again, this relates to transformations because the translations, reflections, and rotations will all create congruent shapes. The second thing that this relates to is equations. We haven't really reviewed equations in a little while, but if I tell you that one side is like 3x plus 4, and the corresponding side is like 4x minus 5, you could go ahead and set those two sides, those two expressions equal to each other and solve for the missing side. Now, since I just made those two expressions up, I very well could have created something that was a negative number, so I'm not going to use those, but I'm just using it as an example. And when we get further into this lesson, you'll see that there is an actual example to practice that. So that's congruency. The second thing we're going to review is similarity. And we've done this with similar shapes in previous units, and we've also talked about this using proportions. So when this relates to transformations because dilations create similar shapes. So again, what you'll notice about these similar shapes is that they're like the congruent shapes and the fact that the angles, the corresponding angles are equal to each other. The difference here is the sides are in proportion. So 8 over 4 equals 10 over 5 equals 6 over 3. So the corresponding sides are going to be in proportion to each other as opposed to equal to each other, like when we were talking about congruent shapes. So if you want to go ahead and practice similar shapes, you would say, okay, well, I'm telling you that these two are congruent, and I'm telling you they're congruent in the way that they are, meaning they're not turned or anything. So I could say that 4 over 16 equals 2 over x. And there are 4 different ways to create this proportion. So if your instinct is not to create it like this, but your instinct tells you, just by looking at the shape, that 4 times 4 is 16, so 2 times 4 would have to be 8. That's fine as well. But if you were to solve this proportion, you would get that same answer. And if you were to create any of the other 3 proportions that compare these two shapes, you would also get that x equals 8 piece. So this is just a mini review. The place where it gets a bit trickier now is, which you're going to see in a bunch of your problem sets, are questions like this. So it's giving you a congruency statement. It's telling you that triangle test is congruent to triangle Hague, and it wants you to solve for x. So in order to do this, the first thing you're going to have to do is identify the corresponding sides. There's going to sometimes be too much information. It's just a fact. They're going to give you information that is too much for the problem. So if I were to look at this, I could tell by the congruency statement that TE and HA, TE, HA are congruent to each other, and congruent is just a fancy way of saying equal. So I could go ahead and create an equation that has these two sides equal to each other. And then I could go ahead and solve that equation, remembering my variables on both sides. And my goal here is, again, to isolate the variable. And when I go ahead and isolate the variable, in all the many steps, I get x equals 6. Remember, that x equals 6, that doesn't mean that the side equals 6. This has been a constant mistake and something that we have to pay very close attention to. In this case, x equals 6. So in order to find the length of this side, if that's what the problem was to ask for, I would have to plug 6 back in. In this particular problem, it does tell you to solve for 6, so solve for x, so your answer would be 6. However, if I said what is the length of TE or what is the length of HA, you would have to go ahead and evaluate and find the length of the side. And again, just to make sure that you found the right x, if you plugged it into this side, you should hopefully get the same 45 as your answer, and you do. Okay. So once again, if I give you a problem like this and I say solve for x, your answer is x equals 6. If I tell you to solve for the missing side, you're going to have to go ahead and plug it back in. This 8x plus 5, too much information. I may ask you to find the length of AY. That would use the same x equals 6. Because the only information that you know are that these are congruent shapes, and the only sides that you have that are congruent to each other, that both have a value or an expression attached to them, are these two. So you would have to use those two to solve for your x, and then evaluate any sides to find that missing side. And then a problem with, this is now a similar figure. So in this case, we have lots of information, and our goal is to solve for x. So I'm just going to use the JU, and the reason I'm going to use JU is because it's a binomial, it's an expression, and in this case, because it's a binomial, there's a trick with making sure you put parentheses. So I'm going to say, okay, JU to MA should equal JS to MR. And the reason I'm using JS to MR is because one of the things that you have to make sure of, because of the skills that you have, is that one of your fractions, okay, has a number compared to a number. When you get into algebra next year, this won't be so much of an issue, but for our purposes right now, you have to make sure that one of your fractions is a number to a number. Or that there's only one binomial in your proportion. So when you go ahead and solve this, when you cross multiply, you have to make sure that you put parentheses. This has been a constant bit of confusion for us in solving proportions with a binomial as either the numerator or the denominator. We have to make sure, because you are multiplying 5 by the quantity of 2x plus 4. 2x plus 4, even though it's a binomial, represents one single number. So you have to make sure that you are multiplying 5 by the quantity of that. And then when you go ahead and you solve, right, so now it becomes a bit of a distribution problem. And now from here, it should be a bit of an automatic. And again, here it says solve for x, but if it were to say solve for the missing side, right, you would plug 8 back in. And you would get 20, and then you could say, okay, 20 to 4 is the same as 25 to 5. And that should make sense. 24 to 4 is 5, 25 to 5. Yeah, 25 to 5 is 5.